have a couple of other panelists I'm going to invite up to join us here on the podium, and then we'll take some questions from the audience. So first, Karsten Hauschild, why don't you come on up? In fact, you can all come up and I'll introduce you as you're up here and give you a chance to say a few words. So we've got Eric Barnstead from Microsoft and Keith Higgins from Foghorn Systems to just give us a couple different views on this whole ecosystem and some of the challenges. So why don't we just work down the panel quickly. You can introduce yourself and tell us a little bit about what you're doing here.
Sure, thanks, Greg. Carsten Hauschild, I'm part of our global line of business for digital products and asset management. So you see it's not only about asset management, it's about the whole digital supply chain management solution we offer to the market, and we are basically responsible for that product portfolio worldwide. So I'm originally from Germany, as you probably can hear, but I've been living in New Jersey since 30 years, so I have dual citizenship, a wife, a dog, a mortgage, so I'm stuck in the US quite happily.
And it's a strong New Jersey accent, too.
Yeah, German and New Jersey, isn't that great?
Hi, my name is Eric Barnstead. I lead the Azure Industrial IoT team at Microsoft. I've been living in Ireland for 16 years and 2 years in Redmond, so I guess you could call me Germish. But I'm living in Munich now. I'm also pretty active in the OPC Foundation. I'm on the Technical Marketing Control Board, and I'm also the representative of Microsoft at the platform industry for Working Group 1.
Thank you. My name is Keith Higgins. I'm representing Foghorn Systems today.
Pull the mic.
One of the companies that probably doesn't have quite the brand recognition of our two partners here, by the way, SAP and Microsoft. So the premise of Foghorn was really to deliver technology that would get analytics and machine learning, and I think this is something Greg touched on, as close to the edge of the data source as possible, where there's not a lot of computing resource, there's not a lot of bandwidth in some cases. We recently closed a round of funding that brings the total just north of 50, and they included Intel, Honeywell, GE, Dell, Bosch, Yokohama, which was mentioned in an earlier presentation. So Silicon Valley company building technology very complementary to the cloud and very focused on delivering it primarily through OEMs and their IoT gateways and platforms by delivering a stack that does many of the functions that Greg outlined today.
Great. Well, thank you very much. So we want to take some questions from the audience. So while you're thinking about the first question, and who's got that, Ken, I don't want to let you off the hook too easily. So I've got a question for you to follow up on your presentation today. So there was a bit about platforms, and there was a bit about standards. And I think we see the importance of these things. But what about business outcomes? What's your goal in all this?
Yeah. Okay, so one of the fundamental goals is driving up the integrity of the information. Okay, and that's spoken as an IT objective. But from a business objective, certainly the whole idea is that we do move into the digitalization world, and we do start getting ourselves in a position where we can improve productivity and improve efficiency and improve the operations of the plant, as well as being able to offer new products and services to our customers.
Okay. So let me just throw that open to the panel a little more broadly. Is this typical of the kinds of business outcome that you're seeing your customers target, or is there something else?
One of the things I would say is that you mentioned open standards and how important interoperability is. Completely agree. One of the premises of this panel was around sort of the App Store for IoT. And what I will say is a great number of customers to the business outcome piece are viewing these algorithms that they're developing as a competitive advantage. And so, there's so much of the intellectual property that's being developed by very large companies that they view as key to their success versus their competitors. And so I think there's a little bit of a fine line in terms of, hey, we want to be able to interoperate with everybody in our ecosystem in an open way, but we also want to hold the secret sauce that makes our efficiency, makes our productivity, makes our quality, makes our safety, makes our yield, whatever those things are, versus our competitors kind of closer to our vest. And so that's a bit of the sort of business outcome angle that we see a little bit.
No, and I would absolutely agree with that. And what we see is that if you can get the basics right through open standards, that allows you to focus more of your attention on that secret sauce.
Yeah, I agree with that as well. So obviously open standards are a necessity. I don't think there's any disagreement here. It's definitely the key to success. But yeah, the customer doesn't want to just adopt technology for the sake of technology, but they want to transform their business. And that digital transformation is enabled through technology, but the real transformation happens in your business transformation, creating new products that you couldn't create before, usually outcome-based products rather than just selling hardware. And these outcome-based products allow you to, while you're still making money with your traditional business, go into a completely new business area where you're, maybe offering services, offering things that, great, thank you. Things that allow you to, expand your product portfolio in ways that you couldn't do before.
Does it work here? It's a really interesting topic, this whole, when you hear business transformation, digital transformation, if you take a step back, what's going on actually across multiple industries. If you look at the, let's say, product lifecycle, the supply chain, you design a product, you manufacture, you sell it, you transport it, and then you put it into operation and you service it. What's going in the industry, because or as having IoT and the digital, all these cloud solution, cloud applications as enabler, what's happening is actually, you probably know that experience at its best every day, wholesalers become retailer because of technology enablers. It's much easier, faster for you as the end consumer to go on Amazon and buy something, and the wholesalers originally they become very intrinsic, embedded in your life, and they get a lot of insight into your behavior. That's one example, wholesaler becoming retailer. More interesting example is transportation. If you look at, okay, I produce, manufacture, I transport something, and then I put it in an operation. And think let's say you have your manufacturing operation in Europe and your customer sits in Australia. So transportation companies, they're actually changing their business model. They become manufacturer. Because they have 3D printing machines in their warehouses and locations. They build farms of 3D printing machines. So they transport not the physical good anymore, they transport the digital twin. And of course it's fast like this to move from Europe to whatever, Australia, have a 3D printing machine sitting in Australia and you get your spare parts in an hour and not after 2 days or 3 days when you ship this. Or manufacturer, it's another example of what digital transformation really means. It's changing business model. Manufacturers becoming service providers. Let's say you're a air compressor manufacturer. You don't sell the actually air compressing machine anymore. Yeah, you sell compressed air. So the machine, the equipment that's at the location of an operator doesn't even belong to the operator anymore because he just buys whatever 100 cubic yards of compressed air to a certain price. And the manufacturer is actually responsible for keeping, in this case, it's his asset up and running. So the customer who signed in basically a service agreement has all the air he or she needs all the time. So that's kind of some examples when you hear this term digital transformation. It's not about IoT and all this stuff. Yeah, those are technology enablers, and it's really about, and then there was your question about business outcome. That is the business outcome. Companies, they can change business models. Yeah, they can make more money and totally change how they are perceived in the market. So that's just
Okay.
overall. I mean, Ken, you talked about one certain aspect, but if you look at the total industry, it's really fascinating what's going on right now, and it's moving very fast.
Greg,
So-
that might be a question for you, actually. You know, with all the customers that you have,
In the mic.
with all the exposure you get to companies in the midst of this transformation, how many of them have shown you a hard number on we invested this much, we returned this much?
Okay, no fair talking, asking questions of the moderator. It's not in the game. No, I mean, it's early stages, so those kind of numbers are pretty hard to come by. We do get a lot of information, under non-disclosure from a lot of our clients. I don't think we've gotten a lot of that particular
That makes me
data.
feel better because we haven't either.
I think we have some questions in the audience, so, yeah. It's a little hard for us to see up here, so just go ahead.
I wanted to kind of focus this back again and take this back again to openness or open systems or whatever. We all agree that digitalization has to be predicated on openness. I mean, that seems to be a consensus. However, I get the sense that we go through different periods of how we define openness, what is openness, as we go through different evolutions of both IT and now OT, and now we're moving this. We're connecting the intelligent edge to a platform, to a business platform, and so on. Any of you talk about what is actually going to define the new generation or this new era of openness, and what will it be in terms of not necessarily some code that you can download and develop your system, whether it's embedded systems or whatever it is, but what, as I think as Keith mentioned, that we still want to hang on to the secret sauce. Well, how do you differentiate what your value proposition is going to be in this new open environment? Because after all, the Internet of Things, the Internet is the ultimate open system. So how are we going to navigate that in this new era of openness, if you will?
Mm-hmm. So for Microsoft, openness means the platform is open, right? So what that means is there's no secrets in the way that the platform is implemented. Most of the components of the platform are open source and people can look at it. But how a platform vendor, or specifically Microsoft, makes their money is by renting out that platform to you, and you pay us per month for using the platform. But there's no more vendor lock-in going on because the platform is open, it's based on industry standards, and you no longer have this fear of being locked into using a platform and not being able to get back out again. So this area has passed, right? This is behind us now, thankfully. So now it's all about making sure that the platform is compatible or standardized in a way that is repeatable and visible to the customer. So the customer can go in, look at it and say, yeah, I know what all this is, but I don't want to maintain this myself. I don't want to run this platform myself. I'd much rather pay somebody else to run it for me, and I can differentiate on the secret sauce, as it was known, on top of the platform, and I don't have to worry about all this platform stuff underneath it.
Yeah, I would maybe, just to maybe clarify that comment a little bit, I think everybody in the vendor community has said it, how important openness is and interoperability. My comment was really related to, when we work with customers, no machine learning algorithm is off the shelf for their specific problem, right? There's just, every situation is very unique in terms of the types of data, all the protocols, the problem they're trying to solve. There's 100 different things that could, well, probably more than 100 different things that influences that. So they spend their time customizing these models that they believe give them a competitive differentiator and hopefully someday a hard ROI. And they're a little bit sensitive with those to not make those open source because that's core to their business. But I think from a vendor perspective, everyone's in agreement that openness, transparency, we're all using the same models, we're all using the same interfaces. Yeah, the way we work with the cloud is very standard. So hopefully no one feels discomfort with the vendor community's progress towards openness. I think what Greg said earlier is right, which is, we've been talking about all this stuff for a while, but the bigger the transformation, the slower it takes, and we're still in such early days. There's just still a ton of work to be done.
Okay. Do we have a question? Yep.
Can I just answer to that too? Does it work? Yeah.
Get really close.
It's a very good question. I mean, in openness, there are several layers to that question, or behind that question. I mean, when you talk about platforms, openness means also choice. Yeah. So if you look at, we as a vendor, SAP, we run cloud applications on Azure, on Google, on AWS, or we run it on our own platform. So we have choice. Yeah. And with that choice comes openness in terms of the applications, and Ken presented here a use case for openness around an asset registry around, and that is the Asset Intelligence Network at its core. It's your central asset registry, and you can share that information with your ecosystem, based on authorization, of course, or with your service provider, with your other departments within your own company, or even giving feedback to the OEM. So using standards is openness because there are no, let's say, proprietary hurdle to communicate with each other. So that's more on the application side. And then in terms of the secret source, there are certain building blocks. Let's say, predictive maintenance. There are certain tool sets, and you can build your own secret sauce besides whatever is out there as standard methods to predict the failure rate of a pump. But that gives you the competitive edge. You use something and you build around this. But maybe it's only 10% of your overall knowledge that's out there. 90% is standard. Everybody knows how a standard pump is behaving. But you have specific knowledge about the last 10%, and that makes you really special.
Okay.
So there's actually one more comment I just wanted to make.
Let's finish this one.
Right. Another thing is obviously the interface to your machines and your equipment, right? So that's something, a lot of times people come up to me and say, hey, connect my refinery to Azure, but for God's sake, don't make any changes, right? So the only way you can implement that is by saying, okay, you need to give me an open interface that you support, and then we can talk, and then we can connect things together. But this is something that needs to happen beforehand.
Okay.
Just a quick comment. The vision is like, I think we've all plugged in a printer into our PC, and lo and behold, it just magically works now. And I'm sure you can all remember the days when it didn't just magically work. That's what we want to be able to do with these sensors. Just plug them in, and they just work. The secret sauce is you deciding where you want to plug one in, right? So, whereabouts, what do you want to monitor of your plant? And if you can focus on that question rather than having to say, oh God, how do I get this thing talking to the analytics solution, that's when you can start adding real value.
Right.
Yeah. Okay, thanks. That's a good comment. All right, now let's have a question from the audience.
Can I? I'd like to say that I'm very impressed about this architecture where we see all these standardizations about asset information models coming together. I'm following ISO 15926 since a while and updating myself once in a while, and that's complicated enough, but if I see that everything comes together, it's just mind-boggling how you did that. But then I see even the next step, your bus there, is that the bus modeled on the IIC reference architecture? You have an open bus there?
Yeah, so the bus is open, but it's based on the ISBM. What does that stand for, Alan?
Okay, so
actually on some of the like the industrial internet consortium standards, a lot of their stuff is still more or less PowerPoint engineering in some standards. These are real specs that have been produced and have been out there for a while and actually are getting ready to go through an update.
okay, fair enough. I need to look into it, clearly. There are some DDS implementations, actually, there are quite a lot. But so that I found that interesting that you made that step as well, creating that bus. Where I have a question mark is when we compare what you did or what you do with what the Namur open architecture tries to do together with the open automation, the open group. There is another information model there, and it would be lovely if those two would come together so that we get a real uniform landscape.
Absolutely, and we need to keep driving for standardization of the standards.
Right.
There are way too many standards today.
You did notice on that common solution architecture slide, we had cost Caesar and USPI.
Yes.
The other two principal inputs to ISO 15926. I'm actually also an ISO engineer in those related working groups. I can be one for oil and gas interoperability. Which is taking what Ken showed, which are the industry standards, and overly integrating it from an ISO point of view.
Okay.
ISO and IEC standards there.
Okay, wonderful. If I can help making the connection with Namur, then I'd be happy to do that.
Thank you.
But you've actually just mentioned something interesting and something important. So it's not just about connectivity and being able to communicate with different types of equipment, but the information model also needs to be standardized, because
Yes,
what
it's
you
the
really want
language.
to do, right, eventually is to have a large graph of all your assets, digital twins, in one database that you can run queries over, right? I think the AIN, as well as the work that's being done in the platform industry with the asset administration shell, is exactly the right approach there.
And speak one language when you exchange with other parties, because
Right.
in asset management there are so many parties. That's what makes the thing so complicated.
Correct, and you need a standardized interface for the asset transfer and information exchange as well.
Yeah. Thank you.
Okay, very good. Did we have another question? Yep, here we have, over here.
Good afternoon, Mark Schruffler, Eli Lilly and Company. We have to reconcile the fundamental tensions between openness and security, and so I don't want to take this down a cybersecurity track, but what I wanted to ask the panel was, do you see the OEMs for sensors and components in various pieces of these architectures keeping pace from a security by design perspective? It seems like it's easier to be open and connected than it is to be secure, and that may be the Achilles heel in the adoption of a lot of these technologies and architectures.
So secure by design, maybe. Secure by default, definitely not. And I think that's the real problem. I mean, it's no use having security features if they're not turned on, right? And I think the manufacturers really need to start putting pressure on the OEMs and suppliers to create products that are secure by default and not just by design. I get off my soapbox again, but this is a passionate subject for me, because
I see a lot of heads nodding, so
there's definitely some room for improvement there, right?
Yeah. So security is absolutely critical, and there needs to be a security component to any standard. Let me tell you a real story. We were working with a OEM who said, we will, if you give us your data, we'll monitor it for you as a service. We'll combine it with the data from all our other customers, and we'll be able to do predictive maintenance far better than you can. We bought it. It took us nearly 6 months to get the security approval to pass that data to that individual manufacturer, because it was all a bespoke solution end to end. That during that 6-month period, there was actually a failure where if only we had it in place earlier. And of course, the digital security guys were blamed for that, that situation. When, no, the digital security guys were doing their job. The blame went to the fact that we had to do that security in a bespoke way. If we could do that in a standard way and put in place that security protocol in a matter of days rather than months, we would be far better off.
Okay.
I think that's the key. Yeah.
One of the other things I would add is one of the bigger drivers in the design considerations of edge gateways, of these IoT gateways that are highly distributed, is, you know, how do you deal with security in a very different way than you might think of from a cloud-based service. So it's one of the pillars of why people are moving this processing power closer to the source of the data, and there's a lot happening there from a security perspective that's worth taking a peek at.
I mean, there's several layers to that. Again, it's on a technical level, security, authentication, and all this. And I mean, from an SAP perspective, we have this all built into the SAP Cloud Platform. But if you go up the layers of the stack, if you think about application and sharing of information, then, for example, the Asset Intelligence Network, if you share information across OEMs, service providers, who have access to what? Do you want to even give feedback to the manufacturer about the performance of the pump? If it's well performing, maybe you said, oh, well, maybe I should charge more or less. Yeah? You have this kind of contractual relationship. So do you want to have this? You have to think this through, what it means from a ecosystem at all. And there's sometimes really interesting kind of issues that come up, but they have nothing to do with security or authentication. And also, if you think about one example I had before, where I said transportation providers become manufacturers. So you move a digital twin of whatever, a pump or spare parts across the ocean. You have to make sure that the IP of that spare parts design is protected. So it's a multi-layer issue, right? And it's really, really important when we talk about digital transformation.
Okay.
Thank you.
Thank you. So what I would just like to change this slightly. You know, we've been talking about platforms and clouds, and people conceptualize a lot of this work that way, but we've also seen a sort of countervailing trend towards moving a lot of the computing to the edge. So my question is, how will that edge computing impact the access and types of applications available to industrial organizations? And maybe, Keith, you can start us on that one.
Sure. Well, I think there's some real advantages to putting machine learning closer to the source of the data. You can make decisions faster. There was actually an article, Microsoft was written up about
Intelligent Edge.
your elevator customer.
ThyssenKrupp.
Yes, I think it was, where they said, you know, to get something to and from the cloud can be 1 to 200 milliseconds, and in edge computing you can do it in 1 to 2 milliseconds. You know, by being able to do things faster, you can enable new applications. There's a lot of safety implications with that. You can also really optimize what's done in the cloud. If you do data enrichment and some analytics at the edge of the network, and then what you're sending back helps train those models that are all built in the cloud more efficiently. So the reality is there's a lot of industrial locations where there's very little bandwidth, where there's very little compute. You know, so being able to put that kind of technology into a Raspberry Pi device, into a motion sensor detection kit in an elevator, or something like that, or these really distributed oil and gas applications, for example, really enhances everything that's happening in the cloud. So a lot's been written about the types of applications, the things that need a bit quicker response time, that have security implications, and that have the reality of very limited compute and communications resources, and those are some of the main drivers of this kind of new, rise of the edge, as some people are calling it.
Right, I guess the oil rig is actually the perfect example for intelligent edge and why it's important to have that, including machine learning running at least a runtime on the edge. So, I mean, I'm no driller, right? But I'm told that a drill head is quite expensive and you don't want to break it. So you really want to make sure that you collect as much telemetry as you can during drilling, right? And you have gigabytes of data being produced, and you don't want to send all of that from an oil rig over satellite to the cloud, right? You really want to keep that local and be able to process and analyze that locally. And as you're running your runtime, and you may find that you may damage some equipment, you can make that decision to stop drilling in milliseconds, right? And you may find that through this drill failure, let's say, or you failed drilling, but the drill head is still okay, you've learned something new about your drill head, right? So then when you're finished drilling, you can take that analyzed data and send that to the cloud to improve your machine learning model. And then, your new machine learning model in the cloud, which obviously, you need a lot of compute to process a new machine learning model. So that compute is cheap in the cloud, right? So that's why you want to do it in the cloud. You can then bring that new model, improved model, back down to the edge, and you drill another day. So it's a perfect example for why the intelligent edge is important.
The other final point I would add to that is increasingly sensor data is video. And so the ability to do sensor fusion across audio, video, and digital content is magnifying the bandwidth problem, if you will, and making the models more complex, and even more supporting your point of there's a lot you can learn with sensor fusion in a different way, and then having that tuned in the cloud sent back down to the edge is really helpful with video in particular because of the bandwidth needs.
Right.
Yeah, intelligence on the edge is absolutely crucial because of the big data issue you have. I mean, you generate terabyte of data every day, maybe every hour, based on the business scenario. You cannot just put this up in one big cloud. It's impossible, or could be possible, but very, very expensive because you have to have the bandwidth and the storage capacity, so it doesn't make sense. However, you want to have certain information up in the cloud for further insights. Yeah, if you think about the behavior of an asset, pump or motor or drill head is behaving a certain way, and you want to basically filter out certain interesting information. And then if you think about an asset, well, maybe you want to change your maintenance strategy, your plan, analyzing what happened over the last 5 years with work orders, with information that comes from the edge. Then you need a centralized approach, and you have the data all in one place, but not everything. That doesn't make sense.
Okay, very good.
So I'll say that ideally you want both. You want it in the cloud so that you can develop your model, and then you want it at the edge so that you can run your model in the time between failures. We've got a very good example with optical fiber down wells and distributed acoustic arrays, distributed acoustic sensors. So effectively you have a microphone every foot down the well. The volume of data that produces is about 1 terabyte an hour. The only feasible way of getting it into the cloud is physically shipping the disk. So let's do that. No, there's no problem with that. Once you get it there, you can analyze 6 months worth of data and come up with a really good anomaly detection model. And then once you've developed the model, you take that anomaly detection model and you run it at the edge so that it's analyzing the data in real time at the edge.
Yeah, that's a great example. All right, so Eric, let me put you on the spot just a little bit. So I had a couple slides about ARC's view of what an IoT cloud platform might be. How does Microsoft think about categorizing IoT platforms?
Yeah, so that's an interesting one. Yeah, so certainly Microsoft has the categorization in layers. So down the bottom you have infrastructure. So that's your compute, your storage, your databases, if you like. On top of that, you have your platform as a service, and that's your services that make up an application, but it's the components of the application, not the application itself. And then on top, you have software as a service. So that's your application that you can also, for example, IoT Central is a software as a service offering that we have, where you need to do nothing but log onto a website and start configuring your sensor data, and that's it. Right? So a good analogy is actually food, right? You think of food, infrastructure as a service is you cook your own food and you eat it at home using your own cutlery at your own table, right? Platform as a service is use a delivery service, right? You don't have to cook the food, but you still eat it at home. And then software as a service is you go to your favorite restaurant and you need to do nothing, right? So in that kind of analogy, you can pick where you think you can differentiate, right? If you think you can differentiate building services on top of an infrastructure platform, then you pick infrastructure as a service from a cloud platform vendor and you build everything yourself. If you think, no, that's not really my business is something else, you might look at a platform as a service where you can differentiate by building line of business apps that you can sell to your customers. Or you may be a small to medium-sized business selling, I don't know, components for the oil and gas industry, but you don't even have an IT department, right? You're a really small niche player, but you're like a hidden champion. Well, for you, software as a service offering is ideal because the amount of customization you need to do is pretty low, right? But at the same time, you want to get that insight from your products out in the field. So for you, a software as a service offering is perfect. So depending on who you are and who your customers are, you pick one and then you roll with it.
Well, that's an interesting analogy, the food analogy. So for all of you who are thinking about taking your sweetheart out to Valentine's Day dinner, you can think about software as a service while you're there.
Exactly.
Get her in the mood.
We are still at the conference.
Bring the sweetheart to the conference.
Okay. So a lot of this, we have a question here? Yeah, let's take a question.
Just following up, Greg, with the edge. So I was at a meeting in one company, small footprint, we were talking about edge computing, and senior person there was very concerned about edge computing related to, now I got thousands of computers out of my plant, and how are my guys going to look after all this there? Have you guys heard anything in terms of concerns with edge computing, especially from the maintainability, total cost of ownership there? So yes, totally agree with you on all the power and capability, but what about the whole picture of who looks after all these things, and these things are not that simple there? Just a comment on just from your perspective.
Sure. Well, the answer for us is simple. Most of those devices are already there. We're going into a control system, we're going into a motion sensor kit, we're going into some sort of existing computing device that's already there. So I think one of the biggest challenges that people are going to have is if they don't have a solution they can deploy within their existing computing infrastructure, certainly in certain locations. You're right, nobody's going to put a server rack at every location they want to collect sensor data from. So there is absolutely that concern, but I'd say in a large percentage of times we're going into an existing device that's already there, already being managed, and co-locating with that device.
I think this person was thinking of they have a lot of legacy, and then to go to that, they would have to add all this power there. And it looked interesting, but that was a concern. And I was just curious your thoughts.
Yeah, I mean,
someone that
we've been
starts
able to-
with a legacy environment.
Yeah, I mean, we have customers running 50 machine learning models on a Raspberry Pi device at less than 256 meg. So you can get it done in a very small compute footprint.
I've certainly heard that concern. I mean, if you have a large brownfield installation with 50 different vendors, and now they all come to you and say, hey, we're going to put this black box on premises for you to collect telemetry data from my devices, but only my devices. right? Then you end up with, a rack full of gateways, right, where you have no idea what's going on. So that's why interoperability with open standards is so important. And you say, no, no, no. If you want to bring a gateway onto my shop floor, I better know what's inside, right? And you can tell me that, and then I'll make the decision if I'm going to install it or not. And you have a much better chance of convincing them it's okay, the gateway is not this, black box that's going to hurt you, if it's based on, open standards where the customer can relate to what's actually happening on the bit.
I think the important thing is also have senior management sponsorship and start somewhere. Do little steps. Don't do the whole plant in itself, because then maybe it takes 6 months or a year or whatever. Do a small project so people see there is a payback for this, and it's actually not that difficult, and they see the actual business benefit.
That's one of the points that you bring up is a very good one, which is there's so much legacy out there and so many different protocols being generated by these. That one of the biggest challenges for machine learning platforms is being able to, take in data from all these different protocols. So in many cases, that's why they're front-ending machine learning with some sort of a complex event processor, some sort of a way to terminate all those protocols, unify the data, kind of condition the data before it goes to the machine learning. And those adapters are not simple in some cases.
Yeah, but they're relatively cost effective, right, which is great. So, usually if you have a legacy field bus protocol, getting an adapter to some of those, let's say, modern open standards is not that expensive. So it's worth the investment because, again, it's about the common information model. What use is if you have 50 different ways to describe a type of machine that you may have from different vendors, right? You want to have one information model for all of them, right? So you want to unify that information model.
There's an
Okay.
interesting challenge. How do you go from legacy to open interoperability there in 10 easy steps or something like that?
Okay.
Next white paper.
So there are quite a few vendors that specialize in this, right?
So
you just
let's,
call them up.
we have to kind of close this off because we've got time for one more question, and I see one queued up here at the back of the room,
Well,
and then we're going to close.
This isn't so much a question as a response to his question. I have customers that express the same concern you have, and the solution that we are implementing is that you use web portals to remotely manage the gateways so that the plant doesn't have to manage them. They can be managed by the IT department or the higher level engineering people, because the plants I'm working with have 20, 30 people in them. Yeah, there's no IT people there. That's another way to do it, is to do it through remote.
That's true, actually. So if you need an adapter, talk to him.
Okay, very good.
Greg, can I make one comment on that really quick?
One comment, because we're,
Box that was in the upper left-hand corner of Ken's slide that said OIIE Ecosystem Administration, that's exactly what that's all about. It's basically offloading that ecosystem administration role from engineers and functional people. And an ecosystem administrator actually doesn't need to be an IT expert in all the different bus technologies either. They're a functional expert now that understands how the business works and what systems and apps are getting plugged in and out of that ecosystem.
perfect. Okay, so that's a great note to close on. Well, thank you very much, and please thank our panel as well.